Hi everyone, today I will be demonstrating how to use Vega SDK with platformio inside VS Code IDE in Windows OS. So project building using the Vega SDK uses a makefile based approach. Eclipse IDE works with it in Linux based OS, but here we will be using the platformio IDE for project building and uploading the binary into a RISC development board from the same environment. So this is the must-have file in order to work with the Vega SDK inside platformio IDE with custom Python script based automation. Here platform is set to native because we will be bypassing the platformio compiler. Instead we will be using the RISC-V compiler. Here the build vega.py script compiles the project and upload vega.py invoke the upload tool to upload the binary file into the board. So this is the flow of this work. We will be using platformio UI buttons for building project and upload the binaries. Upon click on build button, the build vega.py script comes into action, and the same for the upload vega.py when we will click on the upload button. With the build script, we will completely ignore the standard platformio compiler, and RISC-V compiler comes into action from the toolchain and the binary is generated. Buildvega.py gathers the board support package code files present in the SDK and compiles them into object files, and then the project files are compiled against the board support package include files, and at last the linker script is linked and the binary gets generated. So this is the project build pipeline. Here compiler is forced for no optimization. Otherwise the compiler optimizes the code in such aggressive and removes some intentional bugs. We will be having some hardware delay, so we have put some empty loops, and for the aggressive optimization the loop gets wiped out. So this is why the compiler is forced to no optimization, and in this path the binary gets generated at last. As previously said, the default optimization O2 aggressively optimizes the code. So this is why optimization is forced to no optimization. This is why compiler flag is flagged at O0. Now comes the uploading method. Upload vega.py script runs the uploader tool to flash the binary into flash memory through the xmodem protocol. Interesting point is that this approach has auto reset facility, so no need to manually press the reset button every time while uploading binaries. While uploading, ensure no serial monitors are open at same COM port on which ARIS board is available, otherwise error will be shown. So this is the entire flow. Write code in C with proper keywords as available in SDK, compile them and upload the binary to the board, and you are good to go. So now time for a demo. Okay, so we will be now going through a demo. So for the demo, we need the Vega SDK, Vega toolchain, and the uploading tool. All of this in a folder. So for this, for the SDK, we will be heading to this link and clone this repository. So git clone, and yeah, Vega SDK is cloning. And we will again clone this, not this repository but the platformio folder only. So git clone and clone it as folder name as pio, and any name you can prefer. Yeah, done cloning. Now we will clone the Vega toolchains for the Windows. It contains the RISC-V compiler for the Windows support. while it cloning, we will download the Vega Flasher Windows. It is the upload tool which we will be using for flashing the firmware into the Aries development board. So clone it. Yeah, done. Git clone. Yeah, done. So we have the Vega SDK and Vega SDK twice as named in PIO. So we will be head to the different branch of this repository, because it is the master branch. You see, this is the master branch. So we need the Aries branch. So head over to the PO folder and run this command, git checkout Aries. No, sorry, not in this folder, uh, in this folder. Run here, git checkout Aries. You will be seeing this, some files will be changed. Yeah, done. So we have now the Aries board supported all SDK examples here. Now we will be copying this file from this platformio folder. We will be copy this libvega.a file. You can say it as the zip file of a pre-compiled object files. So without it, we will be getting error for while uploading. So we will paste this inside the Vega SDK BSP folder and we will place it here. Okay, now we have almost set up. Okay, now go inside the PIO, now platform IO, and here I will be opening the VS Code. Okay, my VS Code ID is open here, platformio.ini. Now we will have to set this path. So first we need the Vega SDK path. It's Vega SDK. Okay, it's here, Vega SDK. We will copy this path and paste it here. Yeah. Okay, now Vega tools path. Now Vega tools, here VS Code is suggesting me the same path. Okay, now all those are same. Yeah, it's inside the same folder, Vega tools Windows, Vega Flasher Windows. So you have got it here. Okay, done. Now we have here, I used it previously, so I am deleting it and I am getting a new project which is not present in the Vega SDK repository. So it is here. Now copy, then paste inside the script. Okay. Okay. Here it is, the main file, main C file. Here we will be seeing a LED breathing effect. The LED will be looking like it's breathing, and we will be using the HX8347G 2.4 inch TFT display, which is used in the Arduino IDE as it is at the sealed. So we will be displaying some graphics on this. Okay, so this is the platform I have build button. I will be building this. Yeah, it's building. Takes little bit of time. Yeah, it managed to build successfully, and the binary is present here. Here the .pio file folder and aries v3 and c main.bin and main.elf both are generated inside this folder. Okay, so now let me connect the board, and the board is connected. Here I will be selecting the COM port. For my case it is COM3. Okay, so now I will upload the binary inside the board. Okay, now it's uploading. Failed. Oh, sorry, Terraterm is opened here. We will be building this project again. Okay, let's see building. Yeah, it built successfully, and then we will connect the board and upload. For my case, my board is connected into COM3, and you see uploading to COM3 main.elf. And as I said, it has auto reset, and I didn't press the reset switch manually. So okay, yeah, okay, let me open the Terraterm and see you the terminal logs. Baud rate is 115. Okay, okay, let me reset it first. And let me show you the live feed of the board. Okay, once again I am pressing the reset button. Okay, now see, and this is the setup, and initially the LEDs are blown up. Now this is the connections, and it running some test. Yeah, like this, and the LED breathing effect I was talking about first, like this. And this driver code is developed by me with the help of AI, and this is not an example from the official SDK includes. This is custom and ported. Thank you.